In this lecture, we will see the schematic of a two-input OR gate. We all know the symbol of this OR gate. We are very much familiar. This is input A, this is B, and this is output Y. Y is A or B. We can write A plus B. Now since this is the plus operator, the NMOS will be in parallel, and the PMOS will be in series. The NMOS will be in parallel and the PMOS will be in series. Now, if I want to obtain A or B, we have another way. NOR plus NOT is equal to OR. That is, A plus B bar is NOR, whole bar will get A plus B. This is one way, and we will implement this A plus B in terms of PMOS and in terms of NMOS, and the output obtained will be, if I implement here A plus B, if I try to implement by keeping all the NMOS in parallel and PMOS in series, then I'll obtain an output as A plus B bar, that is same as your NOR. So I will apply a inverter which will all of course contain NMOS and PMOS. This will give my output as A dot B bar whole bar, which is equal to A plus B. So this part will constitute my NOR part, and this part will constitute my NOT part. So I'll get the output as OR, the two input OR gate. Now let's see the schematic. Let's draw the schematic using this rule. This will be our schematic 1. Since we will draw the twisted diagram also. So this is my schematic 1. Now I have to place the PMOS in series and the NMOS in parallel. This is my PMOS 1. PMOS 2, so this is VDD and this is ground. This is my input 1, and this is my input 2. So this is A and this is B. This is my PMOS 1, PMOS 2, NMOS 1 and NMOS 2. So if this is my VDD, as we know, the PMOS source is connected to VDD. So this is source of P1, this is drain of P1, this is gate of P1, and similarly this is my drain terminal because we obtained the output from the drain terminal. So this is drain P2, this is source of P2, this is gate of P2. Now if this is drain, this is source of N1, gate of N1, and this is drain of N1, this is gate of N2, drain of N2, and this is source of N2. So here we get a common source for of NMOS. Earlier we got a common drain for PMOS. Okay, now the obtained output from here will be A plus B bar. So here we have to design a inverter. We are very much familiar with the inverter schematic. This is the ground and this is VDD. So the obtained output will be A plus B bar whole bar, that is equal to A plus B. This is our OR gate. So similarly we have, this is our P3 and N3. Let's name the terminals. This is source of P3, gate of P3, drain of P3. This is drain of N3, source of N3, and this is the gate. This is the gate of N3, this is the source of N3. Here we have the common drain. Now the output of this is the input of this. So this is the schematic of a two input OR gate. Now we will see the twisted schematic of a two input OR gate. Schematic. This is the schematic of a two input OR gate. So how will you draw? So we know that we have to design the PMOSes and then the NMOSes. PMOS in one side, NMOS in one side. So there is our two PMOS of the NOR. Similarly, just beneath it, we'll have two NMOS twisted, where these two are connected, these two are connected. Then we have the inverter. So this is the PMOS. These two are also connected. This is P1, P2, N1, N2, P3 and N3. Now here let's name the terminals first. We have the drain of PMOS1 and source of PMOS1 shorted. Then this is the source terminal of P1. This is the drain terminal of P2. We have common drain of N1 and N2, and these are the gates. Similarly, this is source, drain, this is drain, and this is source. Now this source is connected to VDD. This source is also connected to VDD. We have common drain. This common drain is connected to this drain is connected to the common drain, and these two sources are shorted to ground. Since the NMOS are in parallel, and over here the two drains are connected. From the drain we will obtain the output. From here it is connected to ground. Now this output is A plus B bar, which acts as input to the inverter, and the obtained output is A plus B bar whole bar, that is equal to A plus B. To input OR. Now we have to draw the layout according to this. So this is the twisted form. This is this twisted diagram for a 2-input OR gate. Now let's see how to draw the layout from the 2-input OR gate. We know these all will be connected by metals, and these will be connected by poly, and here there will be a connection between metal and poly. We know poly is red in color, so there will be a connection over here, and the connection, the contact placed, that will be placed will be purple in color. This is the poly contact. Now let's see the layout. Let's see the layout from the twisted form. First one is layout 1, that we will get from twisted, the twisted schematic. So first we have to draw the layout for the PMOS. So this is the anvil. This is the anvil for the NOR, and this is the anvil for the inverter. After anvil we have the P diffusion layer. This is the P diffusion layer. This is also the P diffusion layer. P diffusion layer. Similarly, we have to place the, now this is our PMOS part. So now we have to design the NMOS part. The N diffusion layer is green in color. This is the N diffusion layer. Now we have to make the poly layer, so that you can find the gate connections first. This is poly 1, and this is poly 2, poly 2. This is the poly layer 1. Okay, now I'll draw the poly layer for the inverter. So now, after drawing the poly, let's this is the poly layer. The poly layer is used to draw the gate. Now we have to connect the, let's name the terminals. The terminals, this is the source, this is the drain terminal, this is the source, this is the drain terminal. This is the source terminal, this is the common drain terminal, and this is the source terminal. Similarly, this is the source, drain, and source. So now the source is connected to the metal layer, is connected by the help of metal to VDD. This is VDD, and the source of the inverter is also connected to VDD. And as we know, there are some contacts placed over here. These are the N substrate contacts. N substrate contact. This is the metal layer. Similarly, we have a contact over here. Okay, now the source, the two sources of the NMOS are connected to ground with the help of the metal layer. This is the metal layer. This is another contact. So now this is the source which is grounded. Similarly, similar to the N substrate contact, we have to place some P substrate contacts. We don't extend this polylayer which will overlap the metal. It's up to here. So this is the P substrate contact. Now this drain is connected to the common drain. Here also there's a contact. And the drain of the inverter is connected to the drain of the NMOS. PMOS is connected to the drain of the NMOS. The contacts. The contacts that are used in the N diffusion layer are termed as N diffusion contact. This is the P diffusion contact. Now these are the inputs. This is input A, this is input B, this is the output Y. So this layer, this output of the NOR is connected to the input of the inverter. So they overlap. Since they overlap and we need a connection, so we'll use a poly contact. This is the poly contact. So this is the whole layout of a inverter, whole layout of a 2-input OR gate in twisted form. Now let's see the layout of a 2-input OR gate without using the twisted schematic, in the normal form of schematic, the one we had seen in the first lecture. So this is our layout 2 from the normal schematic. Okay, at first we have to design the series connected PMOS. So this series connected PMOS is created by placing the N well first, and then the P diffusion layer, N well, then the P diffusion layer. Let's place the poly in order to locate the two inputs. Okay, now this is the source, drain, source, and this is the drain terminal. Now we have to create the two NMOS and their poly layer, that is their inputs. We'll short this input. This is input A and this is input B. Now this is the gate terminal, this is the source, drain and drain terminal. Now the drains have to be shorted. So this is one drain, it is shorted with this drain. And it is connected with this drain. Let's place the contact simultaneously. These three drains are shorted and this is the obtained output. Now this source is connected to VDD, that is the metal layer, and this source is connected to ground, which is another metal layer. So this portion completes our NOR part. Next is the inverter. This is the N-well and this is the P diffusion. Now this is the N diffusion. This is the source, this is the drain and source of PMOS and NMOS respectively. So the source of the PMOS is connected to VDD and the source of the NMOS is connected to ground. These connectors are very important, and the two drains are shorted. This is the P diffusion contact, this is the N diffusion contacts, and the contacts that are present over here are the N substrate contact and these are the P substrate contacts, or this is the P substrate contact. Now we have to place the poly layer poly layer. Now this poly layer should overlap with this metal layer, because this is the output of the NOR and this is the input of the inverter. These two are connected now, and we have to place the poly contact. And this is the output Y, which is equal to A plus B bar whole bar, that is A plus B. So in our next lecture we will see how to draw the layout using magic.